welcome. Glad to have you here. We're going to do a workshop on open science, so just by the fact that you're here, it's great. It means that you're interested in something that's going on in psychological science and beyond. So I understand most of you are in education. Yeah? How many in education? Any of you? Psychology? 2? Okay. Great. So I'll give you a lot of examples from my domain, from psychology, but I'll show you that it goes beyond that. I will also try and make it a little bit more interesting for you with hands-on demonstrations of how to do some open science practices. Let's say, for example, how to do a pre-registration. But I'll walk you through some of the case studies. I just want to say there are lots of slides, there are lots of case studies. I usually give this over an academic year, semester courses. So trying to put everything together with hands-on demonstration is going to be very, very fast. So you might have a lot of questions. So if you do have questions, it's great, but please wait with those until the end. I'll stay with you for as long as you want. But in order to get as much done as we want, I'll go very quickly through the whole thing. But of course, if you do not understand something that I say, if I speak too fast, then raise your hand and I'll repeat what it is that I said. But if you want some clarification questions or something about generally open science and science, then let me know after the talk. Everything that I do, including all of my courses, all of my talks, including this one that we're recording, is on the Open Science Framework and on YouTube. So each one of these domains you can go and follow up beyond. So Open Science Framework looks a little bit like this. I'll demonstrate Open Science Framework, but all of the courses, everything that I do is available for you to look at. So I'll start from something very obvious. For me, it was something that I thought a lot about during the pandemic, is that we're facing a lot of major challenges. Now is the age, after we finish with the pandemic, the age of mis and disinformation, the growth of AI, we have climate change, all these big challenges that are happening. How can we tackle this if we don't have credible, optimized science? So we can't afford 5-10 years in order to get something done. If we have a pandemic, we can't afford 2 decades to do research for climate change. So we need to make sure that we have credible, optimized science. So my first question to you, given that you're in domains here at HKU, you're doing science, how is science doing according to your perspective? So I want to show you some signs that I perceive around me, not just in psychology, but beyond, that something very strange is going on that we need to pay attention to. So this is a case study, not from psychology or education, this is from cancer biology. So cancer biology started in 2012, given something that I'll talk about a little bit later, signs that we might need more replications. We need to revisit many of the classic findings. So they did one big study in psychology, and we'll talk about this in a bit, but they also started something in biology, because they said we want the soft sciences and we want the hard sciences, if you can call it that. So this is what it looks like. They started with 193 experiments. So they said all these big findings in cancer biology, we want to know if we can decrease pain and suffering, if we can decrease death. But already something very strange happened during the first few years. From 193 experiments, they were only able to conduct 87 experiments. Why is that? If you go to any academic article and you look at the method section, you'll realize that it's very difficult to understand what is the procedure, what it is that they did. So when they looked at the procedures of all these academic studies, especially if they're published in Science and Nature, 3 pages, 4 pages, you don't know what's going on. So you reach out to the authors and you ask them, what happened there? Can you please share your materials, your data, your code, share all the procedure? And most of them, a little bit like many of our students, they say, lost my laptop, the dog ate my homework, all kinds of things. And then finally, the ones that they were able to complete from beginning to end, from 193, they were able to complete only 50 experiments. So already we understand we have one big problem, and the problem is reproducibility. It's not enough that you put something in an academic article, but you need to have other scientists understand what you did and be able to follow this to arrive at the same conclusion. Reproducibility, number 1. Second is replicability. So out of the 50 experiments, how many did they get the same kind of results? And this is where it gets very discouraging. I won't go over this whole thing, but I'll just show that the original positive findings were p-value mostly below 0.05. When we look at the replications, you can see the p-values are all over the place, not below 0.05. So if we look at the studies that succeeded in all 3 criteria for a successful replication, how many? 2 papers, 11%. How many experiments? 2, 6%. So later I will talk about psychology, we'll talk about education. If things don't reproduce and don't replicate in our field, maybe you can argue no big harm. But cancer biology, if something like this does not reproduce and does not replicate, oh my God, God forbid something happens to us or some of our loved ones, This is a very big problem. It's a big shock to all of us. So how big are these issues? In my personal view, these are very big issues, and we need to pay attention to this to understand that this is happening in our field. You would ask, oh, okay, just one example. Can you give us other examples? No, because we don't do replications. We don't do reproductions. So it's just amazing that in the one that we did, these are the findings that we found for the hard sciences. So over the years, I've been collecting more and more of these big headlines of the replication projects that we've been doing. And suddenly you realize this is not a psychology problem. This is not a biology problem. This is across the many fields. So you can see that in medicine, there's a problem of chemical research, economics has all sorts of things, and even in computer science and in quantum computing, where you would expect things to reproduce very well because they know what they're doing over there and everything is pretty straightforward. Even there, we have a problem, and this is the cancer biology that we talked about. So criticizing other fields is okay. How about my field, psychology? So in psychology, the Center of Open Science, headed by a person called Brian Nosek, started in 2011 to do a lot of replications. The big one was the science paper in 2015. 100 labs tried to replicate 100 findings in top journals in psychology. We're talking about Psychological Science, JPS, the Journal of Personality and Social Psychology. Tried to do all that. And then they had all kinds of initiatives. You see the ML1, ML2. This is Many Labs 1, Many Labs 2. Just as an example, Many Labs 2, 28 findings with 60 plus samples from all around the world, 7,000 participants for each study. 186 authors, 36 nations. So these are mass collaborations. We're talking about millions of dollars, a lot of people involved. And what are the findings? Successfully replicated 14 out of the 28. Half. How about not the psychology journals? Some people said, oh, of course, psychology journals are garbage because it's not a real science. It's a science of blah, blah. It's a weak science. It's not a science. But if it's published in Science or Nature, then we know that the psychology findings are reliable. How about when we try to replicate these? So 13 out of the 21 in Science and Nature. When you aggregate all of these together, all the many labs, all the science papers and the Nature, everything together, the replication rate is 90 out of 190, 47%. So you should ask yourself, how do you feel about this replicability rate? When I was a postdoc in 2015 when this came out, this alarmed me very much. Because basically what it means is that if I come to HKU, I came to HKU 2017-18, and I have a social psychology book that I need to give to my students. It's a coin toss, whether this replicates or not. So I flip through the book and I say, oh, did not replicate, did not. Can I teach this to my students? Can I go to practitioners, to policymakers, people in the field to tell them that these are reliable? And these are our top journals. We're not talking about all of them. This is the best of the best that we have. My summary, and I've been doing this for a very long time, my summary is the replicability rate for social psychology is somewhere between 30 and 50%. And even more than that, in the things that do replicate, the effect size, Cohen's D or Pearson R, the correlation is about half of what was published originally. So these are big implications for all of us, and we need to think about this very carefully. Now usually when I go around the world and I tell people about these things, people react in all sorts of very defensive ways, and they see this as a personal attack on them. And these are the common objections that I have. This is just psychology, so I've shown you this is also in cancer biology and other fields. So this is a general science problem. Some people say, this doesn't affect me. This is happening on a fridge over there. It's on the sidelines. It's not me. But if you're doing science or you consume science, and we all consume science all the time in everything that we do, then it affects you. Some people say, I know that this research replicates. And my question is, how do you know that this replicates? Have you done independent, well-powered, pre-registered replications? How do you know? And then some people say, but I know because there are hundreds of publications. And unfortunately not, and I'll show you why this is the case, that having a lot of citations that does not mean. And some people say, no, but I've seen this again and again. And I'm going to show you that sometimes unconsciously, we do all kinds of things to affect a finding to go in a certain direction. So even if you've noticed this several times, it does not mean that this holds if it would be run by an independent external replicator. So this is my general view before we go in and I show you some of these issues. Some people say, no, you're wrong. I object to everything that you say. There's no problem. There's no crisis. Everything is great. So my general reaction to this is, we can talk about this. I'll show you my evidence, you show me your evidence, and we'll talk about this in general. But I think we should agree that this is time for self-reflection, reassessment, and hopefully improvement. So I really like this cartoon. So sometimes when we talk about climate change and global warming, we talk about all sorts of amazing things like livable cities, clean air and water, healthy children. And then somebody comes up and says, but what if this is all a big hoax and we create a better world for nothing? So let's just create a better climate, better world for. Same with science practices. I think open science, things we'll talk about today, all these things are more transparency, preventing p-hacking, performing replications, open access, and so forth. Some people say, but what if this is all a big hoax and there's no replication process and everything is okay, and we just improve science for nothing? So let's just improve science. If this is good, it's good. Up until 2022, I was pretty much on my own with the open science community arguing this, but then big boost came. So we've got UNESCO that joined us in 2022. So now it's no longer the question of is this needed, but it's more a question of how do we do this. So first it was UNESCO, then NASA and the Biden administration kind of jumped up on this and they declared 2023 the year of open science. Did you hear about this in Hong Kong? No, nobody heard about this at HKU. Everything is very quiet. So people in the EU and people in the US are like, open science, and we are like, we've never heard of it. What is open science? We don't know. In addition, when the G7, like in Hiroshima just recently, when they get together, they talk about open science and the need for open science because we just had a pandemic and we needed solutions and we didn't have this because everything was too slow and too closed. So G7 will promote open science by doing all the principles. So the big leaders in the world are talking about this. So now comes the question of, okay, I want to do open science. Convince me that it's time for reflection and assessment and maybe improving things. How do we do this? And there's lots of things that fall under the umbrella of open science. Some of the things we already know. So for example, as I share this talk, open educational resources is to share with others. I don't know why every instructor does their own slide and starts everything from zero. But in addition, open methods, open data, open access. I found some very unexpected allies at HKU. There's no open science people at HKU, but the librarians really care about this because they care about open access. So we just had Open Access Week in the library, and last year I gave a talk over there. So they really care about this because they pay unnecessarily billions of dollars every year to these for-profit publishers where we block the access to the general public of the research that they funded. They funded us, they funded our research, but they can't access this because it's behind the paywall. And then open peer review. A trust system. When we peer review one another, then it's hidden behind some place that we've never seen. So all this is a trust system, and we aim to address each and every one of these things. So I'm going to start with a demonstration. Pre-registration is one of the more hyped, it's not necessarily the most important one, but it's one of the more hyped things about how to address a certain problem. Thing is, I'm going to show you the solution before I talk about the problem. And this is important because I want you to know what this looks like. Before I show you this, how many of you have heard of a pre-registration? Raise your hand. Some of you? Okay. So about half of you have heard of this, so this is good. Perhaps you even have some experience with this. There are many ways to do a pre-registration, but basically pre-registration means that you have a plan before you proceed to do the research. And not only do you have this plan for yourself, but you put this on a public website with a timestamp so that everybody can see what that is. So I'm going to use something called the Open Science Framework, which is one of many tools to do a pre-registration. In order to do that, if you want, you can follow together with me, but I'm going to use this folder. If you want, you can scan this. If not, you can just follow together with me what this looks like. So I'm going to open this. Yeah. So this is what it looks like. This is the Open Science Framework. I have to admit, it's a very ugly interface. I apologize in the name of psychologists. So some social psychologists opened this up and they did not invest much in the interface. So it's a little bit ugly. But generally, you'll see that under the umbrella of Open Science Talks, so all the talks that I do are here. Under this was last year's education workshop, so 2023. You'll see that when I create this kind of page, I can have a DOI. So I can put this on my CV or in Google Scholar to say I gave a workshop at education, so I can get credit for this and people can cite this. So not necessarily just an article, you can have a DOI for anything. And under this, you'll see that there are some components. And these components, this is my pre-registration. I'll show you in a second what this is. And then you also have files. So the files are here. So later, if you want, you can download the poster or the presentation or everything that we're going to do in this workshop. You'll be able to download here. Plus, you have all the activity. So first and foremost, Open Science Framework allows you to share everything. From the materials, the data, and the code, to things like presentations, your teaching materials. So everything that I do is available here. So I'll just open this component, which is our pre-registration. I'm not going to tell you what exactly this is, but I'm just going to tell you that you will be taking part now. I'm going to ask you for 3 minutes to take part in a survey. But I just want to show you that I've already pre-registered this survey. After you take part, so that you don't know what the survey is about, after you take part, I will show you what the survey was about. Maybe you can also guess this from taking part in the survey. But what I want to show you is that there is a similar interface. So you have these files over here. In the files, I opened a folder called pre-registration, and I dumped into it all the things that have to do with my plan. So what's inside? So inside you'll see there's a document. We'll go over this document. But I also have all of my materials. So I use Qualtrics. Perhaps you do as well. It's a survey software. So I exported everything from Qualtrics. So you'll see the QSF file, and you see the Word file, and everything. Everything is over here. Yeah, the doc file, PDF, and QSF. And in addition, some people don't know this about Qualtrics, even they've used this for years, but Qualtrics simulates participants for you. So even if you just set up the survey and you want to get your students or for yourself to already have a data plan of how to analyze this, you can simulate participants in Qualtrics and then run your data analysis on that plan. So you can see that I already have some simulated data. So this is a pre-registration. There's no real data here. This is before data collection. Okay? Now, this is what I did in order to put everything there. But before, if you remember, I told you that there's a timestamp. It's supposed to be frozen. It's supposed to be something that cannot be touched. This is where you have the component over here, and then it says registered. Registered means that this cannot be touched. How does this work? There's a tab here called registrations. So if we open this registration tab, you'll see that under this registration tab, there's already one that I registered just before the workshop in 2023. And inside, there's a lot of things, including the folder that I uploaded, but this cannot be changed. So everybody can go and see that it has a date, it has all the files in it. If I open it, you'll see it says on top registries, so this has been registered. It says everything that I do, and I say, please look at the pre or pair registration folder, and then it sees all the files that I included in it. If I really want to see all the frozen stuff, then I go on files, I go on the archive, so this means archive cannot be touched, pre-registration, and then it has all of the stuff that I uploaded before. But this is forever stuck. I can't change this. Everybody can always go there and see what is it that I pre-registered before running the data collection. Is that clear? Yeah. So if we go back here, you'll see that actually there's a main folder with the pre-registration and results. These I can change. This is no problem. But here I have the archive with the frozen pre-registration, and this cannot be touched. So once I go on registrations and I do, let's go here. So if I go on registrations and I do a new registration, then it gives me a selection of all kinds of templates. I use the open-ended registration because I have my own template, and then I go here and then I can create a draft, and then I can update this in all sorts of ways. If you want something more elaborate or more structured or more straightforward, you can use any one of those. So for example, we do a lot of replications, we do a lot of register reports, so you can, some people do this on secondary data, some people have qualitative research. Depending on the kind of research, you can have a pre-registration profile. Okay? Any quick questions about this? Is this clear? Pretty straightforward, right? Okay, so I already pre-registered this in 2023 based on the hypothesis of what's going to happen now. So now we're going to do a little bit of, we only have a very small sample, but I'll ask for 3 minutes of your time in order for you to participate in this. So you can scan this code, or you can go on this website and then see a question, and it's very relevant for today's workshop. So I'll ask for 3 minutes. Go through the questions. It also gives you an idea of what a survey might look like in psychology. If you can't open this or you have some kind of problem, please let me know, okay? So I'll give you 3 minutes, work on this, and then I'll show you what this is about. But as you're going through this, you can already have a hypothesis of what the research is and what is it that I'm aiming to do. So I'll just tell you, I'm a judgment and decision-making scholar. So I study all kinds of behavioral changes to try and get people to behave in a certain way. So obviously here, we're talking about the practices of open science. We have 3 different practices, right? So we had, so this is the pre-registration. So I just opened this from the frozen archive. So I opened the pre-registration document, and it looks like a regular manuscript. You can see it has corresponding author and contributorship. Even has like a placeholder for an abstract. And these are the hypotheses that I had. So I had the hypothesis that we have 3 different conditions. Everything is a within subject design, so repeated measures. Each of you answered all the measures for all the open science practices. So basically, I wanted to see what's the impact of defaults, what the default is to do open science, not to do open science, versus a control condition of having no default. So I wanted to see different open science practices. So we have a pre-registration, we have registered reports, which we'll talk about, and I have data and code sharing. In the same directory, I already have all of the planned data analysis in advance. So this is what was inside. So it has R Markdown code plus Jamovi. Perhaps you're using Jamovi and you're not familiar too much with R Markdown. So now that we have the data, we can actually download this data. So I'm just going to refresh this because now it has your data in it, not simulated data. And I can just download this. So we'll download this. We'll export this, export data. I'm going to download this with the SPSS format because it's the one that is the most well structured. And I'm going to keep this here. I'm going to download everything to my directory. I'm going to replace this with the real data. I'm going to put yes. And now all I really need to do, because I already have the data analysis plan on my R Markdown, I can just run this with the new data. I just downloaded everything, and then I can do something called meeting. Are you familiar with R Markdown? Have you ever seen R Markdown? Yeah, good, very good. So it just means that R Markdown combines R code and text. So actually here you can see it has headings, and within chunks you can already see the results. So if I run all of this together, so just want to make sure that everything runs appropriately. So it will go through all of the chunks, it will run them together, it will make sure that everything is okay, including the real data, so we have some results already. And now what I can do is that I can create an automatic document that includes all of the both text and the output, the code. So I'm just going to run this. It's called something called knit. You can see the knitting over here. So I'm going to knit this to read it down, which is one of the formats for an R Markdown. And then it will automatically give me all of the results that we have from the classroom. So I pre-registered the data analysis, now we have real data, and now it has this HTML output. So this is what it looks like. You can see over here we have all the different things, neutral versus yes, neutral versus no. I'm just going to show you the most important diagram, plot, which is here. So what you can see here is we have the defaults. Default to do yes, open science, no, if there's a default of not doing open science, or if there's a control condition of not doing open science. So it seems like you all came here for an open science workshop, so if I don't give you any defaults, you're already very high. You want to endorse open science, which is great. But all of you indicated that if the default, like it is in HKU, is not to do open science, then all of you drop below 50%. So we have yes and neutral is about the same. So all of you are already very open science oriented. But if the default, like HKU, is no, maybe you won't implement open science. So we have a very small sample. Is this significant? So we can see all the results. So we can go back up and see that actually the default is very significant. Even with a very small sample, you can see the p-value here is below 0.0001, and the effect size is eta square of 0.24. This is a large effect. In default effects, this is considered for us to be a very large effect. And we noticed this with a very small sample just of people here. So sometimes even with, within subject design or repeated measures, you can run something very meaningful and even show this live to people in class. And I ran this a few times. I ran this in a repeated measures, and I even ran this in a between subject design. And again, I'm able to demonstrate, so this is the first time I ran this in my undergraduate course. This is a between subject design, and you can see very similar to what we did over here. People generally say yes, but when the default is no, then people implement a lot less open science. So this is just a demonstration of how important it is for HKU to either implement open science yes, or stay away and don't tell people not to do anything. But if you go to a lab where people don't implement these kinds of things, then it really affects the way that you do things. So this is what happened with my course. You can see it's almost identical to you. So I gave a research methods course to psychology students last year, very, very similar. So people react very strongly to defaults. This is from this workshop, very similar to what we found here, just stronger results. So this is just a demonstration of how you do the whole pre-registration. First you pre-register. Then you put everything there, including a manuscript and the planned data analysis. Then you collect the data, you plug in the data, you run one click, and then it has everything together, and then you just document everything that you did according to the pre-registration. If you had some deviations, you document the deviations. Is this clear, what we've done here in class? Yeah? Okay, good. All right. So now the question is, why do we need this hassle? Like, why can't we just run things as we used to? And this is because we have a lot of case studies that are very troubling about the need to pre-register a plan. What happens when we don't pre-register a plan? So the shock to social psychology started from 2011. Ben is a very big figure in psychology. He's one of the 4 authors of the social psychology textbook. and very well known. And in 2011, he published in one of our best journals, Journal of Personality and Social Psychology, a paper that is impossible. And what is this paper? He was claiming, with 9 different experiments with over 1,000 participants, most of them say very significant, he was arguing that people can feel the future. So typically in psychology, what we do is that we put people in front of the computer, we hook them up to a sweat machine, heartbeat, EEG, whatever, and we show them photographs. It could be to scare them, it could be something, in this case, pornographic, so people react very strongly when they see stimuli like this. He was arguing that actually, if you change the design a little bit, people start to react to pornographic stimuli that is going to be presented in the future, randomly presented in the future, which is completely impossible. It goes against everything that we know about the world. The physicists have been at this for a very long time. There is no support for psi. This is what it's called, psi. But he was able to do this. And he was able to get this to one of the biggest journals in social psychology. How can this be? What is this about? So in the beginning we thought, oh, probably fraud. Something is very odd about this. So we looked at all the methods, we looked at all the data, we asked them, could you please share everything with us? We couldn't find anything wrong. And this is why the editor finally decided to publish this, because they couldn't find anything wrong with it. So what do you do when you have this kind of thing published in the best journals? What does this indicate? Could it be that something is wrong about the way that we do science, the way that we do our methods, that leads to impossible results? So one of the first things that you do when you have a finding like this is you run replications. Up until 2011, this is ridiculous, but we did not do any replications. Only when we have a finding like this, and it's published in our top journals, people start to do replications. The first guy was Stuart Ritchie. He is now a podcaster. He left academia. He had enough. He tried to publish this in JPSP. When he submitted his 3 unsuccessful attempts to JPSP, what was the response from the journal? We are not the journal of failed replications of BEM. We only publish novel findings. Reject. So finally, he needed to go to the only journal back then, PLOS 1 just came out, willing to just focus on rigor without any contributions or theoretical advancements or anything. He got this published. And people were very upset about this. Started an open science movement that was calling for JPSP to revise their ways. Finally, a year later, with somebody, Joe Simmons, who Data Colada, if you heard about him, finally they were able, with 7 experiments, to get this into JPSP again. But you can see all the failed replications of BEM. Has the BEM paper been retracted? Is there any notice on it showing that this is not, is there any link between the replications and the original one? Nothing. So the original one is still there, it's still getting citations, people still say we can feel the future and all that. So Stuart Ritchie, if you want to hear about his story, he published this wonderful book, Science Fictions, and he has both a newsletter and an amazing podcast where he discusses these things. Strongly recommended, very interesting and entertaining. He's also a prolific researcher, so he did not leave academia because he got thrown out. He decided to leave because of everything. So what could have led this BEM paper to be possible, although the outcome, what he was showing, is an impossible phenomenon? How can he get these significant results when he's studying something that just cannot be? This is when in 2012 we realized in psychology that we have something called questionable research practices, or p-hacking. There's something that we can do in order to push the p-value to be below 0.05, even though it's not supposed to be below 0.05. So here's an example, very famous case study from 2015. A big communicator, a science writer, decided to do a study. This is a real study, and the study was linking chocolate to weight loss. And this is the news that we've always been waiting for. We all want to lose weight, and now we know that the best way to lose weight is for us to eat as much chocolate as possible. So you can see all the big headlines. The Huffington Post has the world gone cocoa. Eating chocolate can help you lose weight. People were very thrilled about this. And every once in a while, you open the social media and they will say something about, do you drink more wine? You do all sorts of things that are not. Eat more burgers and you'll lose some weight. So obviously something is very wrong about this, but this is a real study. And after a while, John over there came up with this admission, and he wrote, I fooled millions into thinking chocolate helps weight loss. Here's how. So he shares how he's doing this. Here's a dirty little science secret. Now I'm sharing this secret with you. You can do the same. If you measure a large number of things about a small number of people, you are almost guaranteed to get a statistically significant result. So what did he do? He measured 18 different things. He measured weight, cholesterol, sodium, blood proteins, sleep quality, well-being, blah, blah. Did he disclose all the other 17 things? No, he did not. But just by the randomness of the universe, one of these is going to come out significant. In addition, not only did he do this, but he ran this only on 15 people. The smaller the sample, the wider the noise, the error sampling. So just by the randomness, it increases the chances of one of these 18 things coming up. Even then, it wasn't enough. He wasn't able to find it, so what did he do? One subject was dropped. He looked at the data and he said, oh, okay, he was probably sick that day, let's just remove him and then everything. And this study design is a recipe for false positive. So this is how you can get significant findings. How do we know that people are doing this? Because Daryl Bem, who wrote a very famous journal article about how to write empirical journal article, gives advice to you, to graduate students, to scholars, how you should write. There are two possible articles you can write. The article that you plan to write with a pre-registration, or the article that makes sense the most now that you've seen the results. They are very the same and the correct answer is B. But the correct answer is not B. You should follow the plan. If you did not follow the plan, you should be very transparent about the deviations that you did from that plan. You do not hark, you do not hypothesize after you've seen the result. But a lot of famous articles and books give this kind of advice. You look at the results, oh, they don't make sense because it's not what. Okay, then you come up with a hypothesis, or you play with this, or you take down participants, or you take down conditions or measures. And this leads us to a big problem, and I feel this problem greatly in the last 6 years since I came to HKU. On one side, we've got researchers who really want to do good research. So we care about everything. We care about novelty, but we also care about replications. We care about interest. We want this to be interesting findings, but we also care about them being credible. We want to collaborate. We want to have diversity. We have all these things that we want to promote that are underlining solid research. But what is it that the incentives at HKU and the world around is about chasing all kinds of metrics? What metrics do we worship at HKU? The impact factor. We need to get as many publications as possible. I don't know how it works with education, but for us, we have our top journals. We have the REF, we have the 4-star. We have to go for that. And what do they publish? Only p-value lower than 0.05. Only the most groundbreaking, counterintuitive, crazy things that you can imagine. Innovation. So all the other things that focus on rigor. We want novelty and innovation, but we want this to be credible. All these things are taken aside. So we have this strain. It's almost like a competition between what is it that we came to do in science and what is it that the system rewards. There's this big paper from 1975 on the folly of rewarding A while hoping for B. He was talking about teaching and research, that we are rewarded for research, but they expect us to be good teachers. Are we good teachers? No, we're hired for our publications. So he was talking about teaching and research. But to me, this also is what we are rewarded for is prestige and novelty, but people hope that we also have accuracy and credibility. But I will show you that this is not the case. I don't think we have time for this video, but a very interesting video summarizing what researchers actually do. But I'm going to show you how to p-hack. This is more important than to see a video. We're going to p-hack together. Now, there are 4 different tools in my courses. We use all of these 4 tools, but now we're going to focus on one of them. So bear with me. We're going to see how Bem did what it is that he did. So the nice thing about R Markdown, is that there's something called a Shiny app. And a Shiny app allows you to present a nice interface to people and run a lot of statistics in the background. So this Shiny app, Experience Statistics, is called p-hacker. Train your p-hacking skills. It allows you to simulate a study. So here you can have an experimental group, a control group. So let's say, for example, I really care about fitting the future. So these are, so let's call this amazing condition. And then we have a control condition, and so on. And then we're going to do 20 participants in each group. We can even take this less if we follow the chocolate study. But let's say 20 in each condition. It's kind of the standards of 2011. True effect coherence D of 0, which means that all of the results that I show you simulate having no effect. So if we happen to have p-value lower than 0.05, it's very odd, because actually everything is random noise, should not be any effect. How many DVs do we want? Let's just maximize this, just like the chocolate. We're going to put this at 10, we're going to put some random seed, and we're going to run the experiment. Okay, so I read this experiment. You can see we have all the 10 DVs. All this is supposed to be noise. Nothing should come out. But you can already see DV number 7, just because of the randomness of the universe, the p-value is 0.085. So I'm thinking, oh, this is already promising. Maybe I can do something with this. HKU wants me to publish at Science and Nature. Maybe there's a science paper here. So let's just see what happened with this DV number 7. So you can already see DV number 7 here. And now I'm looking at this, and I'm seeing the amazing condition here. It's already higher, so it's great. But control condition, I see this guy over here. And now I remember, he told me he was sick that day. So I'm just going to take him out and see what happens. So I take out this DV number 7. Oh, terrific. Now I have p-value lower than 0.05. 0.43. I can publish this, send this to Science and Nature, and get promoted at HKU. This is great. So this is a very cynical view of what this might be. This is not what BEM did. BEM actually shared everything with us. So we're not going to do this. I'm going to show you a different type of p-hacking. The good thing about a pre-registration, how does a pre-registration help? You need to pre-register your exclusion criteria. Not after you look at the data, but in advance you need to state who are you going to exclude, what kind of outliers. And if you did not do this, then you need to say very, very carefully, how did you deviate? I did not have an exclusion criteria. Looking at the data, now I have an exclusion criteria. What do? We typically don't say what we did, but we looked at the data and then we identified the outlier. So let's bring this guy back, because we don't do these kinds of things. We understand how ridiculous this is, but now we're going to p-hack. So we're going to go here. And you can p-hack in all sorts of other ways. You can control for a lot of factors, gender, age, the interaction between them. Finally, you'll see that it affects all kinds of things. We're not going to do this either. Okay? I'm just going to assume everything is okay. And I'm going to show you what optional stopping is, because it demonstrates something very important about p-values. There's something called the dance of the p-values. They dance. They go up, they go down. So what I'm going to do is I'm going to draw more and more participants. So I already saw one of them is promising, but I don't have significance. I'm going to call in 5 more, 10 more participants, then I'm going to peak again. Still not, I'm going to peak again. Collect, peak again. And I'll show you what happens. And as I do this, please look at the p-values and see what happens to the p-values. So we're going to add 10 participants. DV number 7, oh gosh, DV number 7 now disappears. I lost my p-value. Okay, let's keep going. Keep going, it really does. It goes up, it goes down. Suddenly DV1 and DV9 maybe seem promising. No, lost. DV9, DV1, okay, maybe. Oh, DV1 is getting closer. Okay, let's keep going. Oh, now getting to 0.06. This is terrific. So maybe DV number 1 is the one for me. No, lost it. Gosh, goes up, goes down. I keep going. Now we're already on 200 participants. Will I ever get my Science and Nature paper? I don't know. Oh, DV number 9 is making a comeback. Finally, after 240 participants, we have DV number 9 without outliers, without exclusions. This is terrific, so I can take this and now I can submit to Science and Nature. But let's say that Science and Nature require a little bit more than just one DV. Maybe they want me to be very, very innovative, and they already know about DV number 9. But if I show another DV, maybe something else will happen. So I can keep going with this. And as I keep going, you can see DV number 5 is becoming a little bit closer. And then finally, DV number 7 is now joining DV number 9. And now I have the paper that I wanted. So this dance of the p-values is something that we don't learn about enough. In statistics courses, we don't understand what optional stopping does. Now we know, after BEM, after 2011, that we need to compensate for alpha every time that we peak. You cannot peak every time. You cannot bring a participant and peak, because you're exponentially raising the chances of finding p-value lower than 0.05. So every time you peak, you need to half your alpha. So instead of lower than 0.05, it needs to be lower than 0.025. And then if you peak again, half. Peak again, half. Because you need to make sure that you compensate for peaking. Okay? So this is one of the things that was very, very common. I remember even in my PhD program, this is one of the things that I saw people doing. Like big scholars were doing this all the time. Oh, you don't have p-value lower than 0.05, just collect 5 more participants. So these are many different ways. I just showed you one of the ways, but there are other things that you can look at. Now, the question is this happening in the literature? And I want to show you that it really is. This is a very important tool for you scholars, and especially students. If you don't want to waste your time doing your thesis on something that is not reliable, use this, please, I beg of you. So it's called P-Checker. It's one tool that allows you to do a lot of great things together. It's also a Shiny app. Now, we have tools that allow you to extract all the p-values and all the statistics from articles. StatCheck, I don't know if you've heard of StatCheck. With StatCheck, you upload a PDF, it automatically takes all the statistics, and it checks whether there are some statistical errors. Now, you can take all these statistics from all the journals in a literature. So, for example, one of the literatures that we use to worship is social priming. So, you can see at the end there are all kinds of data sets. So I'm going to take one data set that has to do with elderly priming. So you can see that somebody went through all of the big papers for social priming and just entered all of the statistics in there. The statistics and the p-value. And what's nice about this Shiny app is that it automatically allows me to do all kinds of things like a meta-analysis, an automatic meta-analysis, which is remarkable. So if we look at all of these, first thing, it has StatCheck. So you can actually see whether there are some mistakes with the statistics. And you can see that it already flags a few that might be problematic. So we want to make sure that the statistics really match the p-values. Sometimes people round up, they round down. People sometimes report wrong p-values. So this is the first check you want to do. But the second thing you want to do, you want to look at a meta-analysis. And I've done meta-analysis before. I can tell you it's not as straightforward as this. Having a tool that gives you a meta-analysis in one click is amazing, but you need to do this with a lot of caution. But what's nice about this, I don't know if you've ever seen a meta-analysis, but it gives you a funnel plot. A meta-analysis is supposed to summarize an entire literature and gives you an overview of what's happening in that literature. In this case, the effect size is about 0.5, Cohen's d of 0.5. So you can see this triangle here. Maybe I can zoom in on this. So you can see this a little bit better. Yeah. So you can see this triangle here around the 0.05. And if this is a solid effect, then these dots, every study, are supposed to be all over this triangle. This is a good representation of credible literature. However, what you can see here is that all of these points are just on the border of some other triangle. What is this other triangle? It's the 0. So you can see that we're missing a lot of dots here. What is this? This is publication bias. Why is this publication bias? Because if it falls under this triangle of 0, when p-value is not lower than 0.05, it's not published. So we reject these papers because we say they're not interesting. So all we have are these borderline, just below 0.05 studies about elderly priming. How do we know that this is a problem? Because we have other tools. We have, for example, p-curve. So we can see the green one is what the distribution of p-values should be. The most should be below 0.001, then a little bit less 0.01, then a little bit less 0.02, then finally the least in lower than 0.05. What's happening in the elderly priming? Most of the results, 44%, are just below 0.05. So we can see that the blue deviates from the green. Okay? How do we know that this is a problem? Because now we have the tools for this. So these studies, do they contain evidential value? No indication for that. If there is evidential value, is it inadequate? Looks like it's inadequate. Studies lack evidential value and were intensely p-hacked. There's indication for that. So now we have tools for you to check your literature. So before you go and spend 4 years on a PhD, take all the literature, plug it in here, takes, I don't know, an hour, run these tools and see what happens. If it looks like it's p-hacked, do not pursue this. Then we have all sorts of other things, excess significance, all sorts of other, and it's really, we can really see with elderly priming, now we have the tools that something is very wrong in that literature. So I do not recommend every year see another undergraduate student trying to do a thesis on something related to social priming. Do not go in that direction. So hopefully this gives you an idea. How do we know, aside from these tools, how do we know whether people are p-hacking? We ask them, self-report. When we ask them to self-report, are you removing some dependent measures like the chocolate? People say 78%. Do you do all kinds of outlier exclusions? Yes, you see all these very, very high rates. This is the first one that we did in 2012, all the way to falsifying data. Up to 10% people say that they falsify data. This is self-admission. I don't even know what it means to actually observe things in reality. Also, we have meta-scientific evidence, just like I showed you with the p-curve. You can see we have a lot of values below 0.01, we have 0.02. This goes according to plan. But suddenly, around the 0.05, we have this bleep of, we can really see that people are pushing their p-value to be just below 0.05. There's a big problem there. Now we have a lot of these studies, so all of these studies just ask people to self-report whether they're doing questionable research practices, and you can see these. It's just unbelievable. This is self-reports of all the people that are doing optional stopping, how many are doing? So all the way from 10 to almost 60% people are doing optional stopping. This is psychology. I don't know how it is in education, but I assume this is about the same. I want to show you another very recent example for this. I don't know if you've heard of Francesca Gino. It's a big scandal that's happened in my field, in social psychology, judgment decision making. Because Francesca Gino allegedly fabricated data, somebody fabricated data for sure. Nobody knows if it's her or she claims her TAs, RAs. Nobody knows. Whatever. Doesn't matter. This is a little bit different. Because of that, Francesca Gino is a very prolific researcher. She has hundreds of co-authors. She has hundreds of publications. So all of her co-authors decided to have a website called Many Co-Authors, where they decided to check all of the data of the things that came out from collaborations with Francesca Gino. One of them, a very prominent researcher in Berkeley, who I know, I follow her work, I've cited her, Juliana Schuler, This is what she came up with as a result of this many co-author collaboration. You can see just how many of these Gina was involved, not involved, just by the hundreds of projects. This is what she came out on Twitter X just a month ago. So you can see October 4th. My final audit from the multiple co-author project is now posted. And because of that, they asked to retract the paper that they did 10 years ago with Francesca Gino. She says, I want to correct the record on 2 immediate false narratives. One, I see no evidence Gino was involved, so this is not about Gino. Gino had nothing to do with this, so it's incorrect to blame Gino. Second, there are issues in every study. I was the student investigator in charge of running studies 3 and 4 10 years ago. The key results were statistically significant due to research practices now identified as p-hacking. She admits, I as a student was under a lot of pressure. I p-hacked. I am ashamed of helping publish this paper and how long it took me to look into this. So just because of Francesca Gino and looking at the paper, suddenly we realize people come up with admissions. Oh, this is what they did in order to get these things. So this is a big problem. Big scholars throughout the psychology, social psychology domain now admit to doing this. Another big challenge, you know this, we don't share any of the data in the code, so you pay my salary, but you don't get access to my work. We put everything behind the paywall. So, and then finally, the peer review is that I refuse to review anything that doesn't have the data in the code. So sometimes I get requests and they say, yeah, give me the data in the code and I'll review this. And they say, okay, thank you for the service, we found somebody else. So this thing about, can you review my research project? Sure. Can you show me what you've done? And the answer is no. Just trust me. Just read the methods. Make an assessment based on the methods. It's a trust system. It's absolutely ridiculous. How much does it cost us when we have these flashy findings that do not replicate? This is from psychology or psychiatry. $1 billion spent to chase a flashy, unreplicable finding. So there's a whole looking at all this, and this is just like one finding. It's so sad to see this. I see this every year with some undergraduate students that follow some of these practices. So we spent about an hour talking about all these issues. You're probably tired from this. And I completely understand this is a little bit overwhelming. I deal with this every day, but for you to just come into a class and see all this, what is this? What's going on? What should we do? So I just want to tell you that there are some solutions. We already saw a pre-registration. We already see a way of Open Science Framework to share some things. But I also want to say there's like a pyramid. A bunch of us in the Open Science community try to improve things. So we start from first make it possible. Open Science Framework was not possible 10 years ago. Thanks for Brian Osick and the Center of Open Science. Now we have this. It still looks a little bit ugly, but it's fairly easy. You've seen how many clicks I needed this. Normative, we really need to work on this because this is not normative at HKU, and I have to say HKU is not an outlier. HKU is very well aligned with the rest of the world. This is not normative. Nor is this rewarding. This is definitely not rewarding at HKU. There's no reward for practicing open science. If anything, it's counter to that. And hopefully one day, I don't understand why these things are not required, but hopefully someday this will be part of our research process. I will talk a little bit about making it rewarding. I will show you some proof of concept with my students and what we've done. So this is the initial solutions, share everything, register reports, diamond community journals. Perhaps if you're at HKU, ignore this. But to incentivize credibility. So now it comes to one of the big solutions. Unfortunately, in education, this is lagging behind, but if you've worked with Luke, or you know Luke, so Luke is very invested in this, yeah, and he'll be able to guide you on how to do register reports in education. I think he was also one of the editors on a special issue or something like that. But things are happening slowly in education. In psychology, register reports are becoming mainstream. So what is this register reports? So right now, I perceive this to be a broken system, but we all take it for granted that this is how science is. We do everything. We develop the idea, we design the study, we collect and analyze, we write the report, we submit this to the journal. Everything is done. All the data has been collected. Then, what do peer reviewers do? They judge us. You did a mistake here, you did a mistake there, reject. What do? Oh, not this journal? Okay, second journal, impact factor. Oh, not this journal? Okay, this journal. Sometimes, and I've had this a lot throughout my PhD, it takes 4 years to go through each one of those. It's unbelievable. It's ridiculous amounts of waste in the peer review system because you don't move peer review from one to the other. I don't even know if some people don't even bother changing the article. They just go until one of them gets. A lot of waste, and finally, they only review when things are too late. You've collected the data. So sometimes they say you need new data. So now you need to throw everything away. Register reports does things differently. The peer review occurs on your pre-registration. So you write the best pre-registration that you can. We do this with simulated data. You submit that to peer review. And then you don't have data yet. There is no outcome. So if the reviewers don't like the outcome, then they reject in the traditional model here. If they don't like the outcome, there's no outcome to judge. So if they see a problem, they tell you this problem, what do? You change it. You improve it. Everybody works together. So all the feedback, when I moved to register reports, suddenly all the feedback is constructive, positive. Sometimes I feel like they're my co-authors. I really want to credit them. So what does this focus on? Did you do your hypothesis? Did you specify them enough? Are the methods appropriate? They help you. Is it well-powered? So no problem of this 20, 30 per. So the big revolution about this is that once you, the editor and the reviewers, come to an agreement that this is the best plan, you receive something called in-principle acceptance. This means it doesn't matter if p-value after data collection is higher or lower than 0.05. It doesn't matter what is supported, what is not supported. You get an in-principle acceptance means that it's going to publish regardless of what the outcomes are. So what happens? So first you get in-principle acceptance. Only then you go to collect your data. And finally, after you write the report, you submit this. This is stage 2. And in stage 2, you don't come up with new things. You just make sure that the authors follow the approved protocol, they follow the pre-registration plan, or documented and justified deviations. So you can go beyond the pre-registration. You can even change as long as you're transparent so that it can be evaluated. So were there enough positive controls, or are the conclusions justified by the data? So it's a very different emphasis. Suddenly, instead of this rigor, novelty, p-value lower than 0.05, suddenly it's all about the science. Is the science good enough or not? So if you want to read about this, Christopher Chambers is the person who started this in Cortex. This is one of our top journals. Well, I wouldn't say that. I'd say tier 2 journal for neuroscience. So some in our department in psychology consider this to be a good journal. And he revolutionized this because he came in as an editor to Cortex and insisted that he only wanted to do register reports. 10 years later, we now have 350 journals that do register reports. So he wrote this summary. So in the research life cycle, there are lots of problems. Lack of replications, low statistical power, p-hacking, harking, publication bias. All of these problems in the traditional model completely disappear with the register reports. There's no reason for you to p-hack because you have an in-principle acceptance. There's no publication bias because it's published no matter what the outcome is. So if there's a problem with power, then it's addressed in stage 1, so that stage 2 actually has enough participants in advance. So all of the main problems in the traditional model are addressed in register reports. Now, Chris Chambers has given hundreds of talks on register reports. I come nowhere close to Chris Chambers, but he's very good at summarizing that this is not just good for science, but it's also good for you, for students. Why is this good for you? I think I have a summary. I have a summary slide for this. This is my slide, but you can go and read Chris Chambers in an official article. So first, there's no stress about amazing and significant results. Your publication does not depend on you having this p-value lower than 0.05. So the risk goes from very high risk, because you don't know if your hypotheses are good enough, to zero risk. Actually, if you look at this, this is what Chris Chambers says. In Cortex, traditional model rejection rates, 90%. Register reports, lower than 10% in stage 1, 0 in stage 2. And 10% is usually just misunderstandings of what a register report is. There's no reason to reject you, because if there's a problem, you can just change the methods. Okay? My experience, my rejection rates, I do a lot of replications and I do a lot of things that consider to be open science, a little bit on the fringe of things. So our rejection rates used to be 70 to 80%. After we started doing register reports, what is our rejection rate? It's 0. It dropped down to 0. I've now been rejected in the last 3 years because there's no reason to reject, because it's an in-principle acceptance no matter what, and everything has been changed. You also get constructive, positive expert feedback, which is very, very important. Maybe you don't have the best plan. Maybe if you work just you and your advisor, you don't know if what you've done is good. But if you submit a pre-registration plan, then experts in the field will tell you if you need to change something. It's faster. I will show you how faster. I do this with my students. You can go through stage 1 peer review in 2 weeks. If you get an in-principle acceptance, even before data collection, you can add this to your CV. This is a line on your CV. This is a guaranteed publication. In addition, if you don't have resources to collect data, no problem. What I do, I go on Twitter and say, I have an in-principle acceptance from this journal, but I don't have enough participants. Who wants to join me? And people say, yeah, I have a lot of resources. Can we join? Because they want the guaranteed publication. I want the resources. Then we collaborate. And then they're added as co-authors on stage 2, and we document exactly what it is that they did. So you need 2 kinds of contributions. One is data collection. Second is going over drafts. So it's an amazing way to collaborate. In addition, to get funding in Hong Kong is very difficult, because you need to convince them they have a lot of risk to take. But if you have a guaranteed publication, 0 risk for the funders. So it's a much better way to do this. So a lot of
Advantages, if you want the most updated list of journals, this is from 2023, it's over here. There's also community feedback if you want to know how well the peer review is going with each one of those, and you can go and click on this. I agree with Chris Chambers, this is his pyramid. I use this with my students. When I read something in the literature that has no pre-registration, that has no open data and code, status quo research, I believe really barely worth a mention. I will not do policy based on this. I don't think you have to, you need to do a TED Talk. Don't publish a book, wait. Now, something that has all of that but open data and materials, I trust it a little bit more, but still not. I wait for a confirmatory study to show me that this actually is supported. So conformity by an independent lab. So pre-registered data materials archive, but registered reports gets a little bit into the green. So once I see a registered report, I think, okay, this is a little bit more credible because there are lots of positive controls throughout the file. And then I hope in a decade that we'll have meta-analyses of registered reports. And to me, these should carry the most weight. So Chris Chambers did this. I added 2 more. I also think meta-analysis should be registered reports. And then we should update them as the evidence comes in. Does this work? We can see a lot of meta-scientific evidence that it works. So for example, the p-value lower than 0.05 is above 90% in traditional journals, but with registered reports, it drops to where it should be, less than 50%. In addition, we do randomized control trials to see how people evaluate the rigor, the methods of registered reports. So you can see when people, without knowing whether this is a registered report or not a registered report, so they're blinded to which condition they're in, they evaluate registered reports to be higher on methods, on quality, on analysis rigor, and overall quality of the paper. And this is a very large effect for a randomized control trial of this. So people, there's some support that registered reports are changing things. And generally, open science is good for everybody. Now, the last few minutes, I will just tell you how I did this with my students. I know in education it might be different. I'm hoping that education will kind of join this. There's already one journal in education that is supporting this. But I do this with my undergraduates and my master's students, MSc. So they have a 1-year thesis that they need to do. And we do this as a registered report. So we submit their pre-registration plan to the journal. So that they get this. Now, how do we do this? Because it's a 1 year. Can you really do a registered report, an entire registered report in 1 year? Yes, you can. Because now we have something called peer community in registered reports, which is a revolution. I need 3 hours to tell you just how amazing this platform is. But one of the things is that it's by the community, for the community. So there's no for-profit publishers. Everything is done on open platforms that are supported by the community. And once you get an endorsement from the community, then you have a long list of journals that will automatically publish your article with no additional peer review. So we're moving things from the for-profit publishers to the community. And then later, if you want to publish this with a for-profit, you could. So this is one of the big revolutions. But the reason why I'm showing you this is that it has something called a scheduled review. So it guarantees peer review within 2 weeks. So this is how I was able to embed this with my thesis students. How do they do this? It's magic. It's called a snapshot. So 6 weeks before you want the peer review, you send a 1-page snapshot saying, in 6 weeks, I will submit my manuscript. They take your snapshot, and in 6 weeks, they recruit reviewers, and everybody targets the same date. You submit 6 weeks into the future, they have reviewers commit to giving peer review 6 weeks into the future within 1 week, and then you get a decision within 2 weeks. So 1 week for the reviewers, 1 week for the editor, 2 weeks you get this. I've done this already more than 30 times. Never fails. They really do this. So it's unbelievable. In addition, all the peer review is open, and you can ask as the author for the peer review to be identified. Why is this important? Because I run replications, and many times the original authors come back with some hostile remarks. I want to know who these people are, so I request for them to be identified. Why is it good for you? If you are the peer reviewers, you can get a DOI citable link to your peer review. You can add this to your CV to say, I contributed to the community. I contributed to the psychology department HKU project. So open, citable, identify. So unbelievable, a lot of things. So I've done this with many, many students. I consider this to be a very successful proof of concept. I'm hoping some of you will try this as well. I won't go into how I do this with the students, but there is a very straightforward process on how it's done. If you want to see some examples, Timothy and Kirk. Timothy has done 2 with me. He did this first in my course, and then he wanted to do this with me in his thesis. Kirk did this, and I want to just show you very briefly what it looks like. So this is what a recommendation looks like for peer community and registered reports. So Chris Chambers, the same Chris Chambers who started registered reports, he's very involved in peer community. So he was the first to really go with us and to say, I want to see how these students at HKU are doing replications. So here we can see, did a replication project, very successful, done everything. You can also see on the Open Science Framework, every step of the way, we share everything. The first submission, the second submission for stage 1, all the randomized simulated data sets, all the data analysis plan, everything is here. After data collection, stage 2, first submission, second submission, third submission. And you can see both the feedback that they gave us and how we addressed each and everything. Everything is open on the Open Science Framework, and everybody can come in and give us comments and check our credibility. Finally, when we got this endorsed by the community, the editor of a journal called Collabra, she is now the editor of Psychological Science, which is one of our top journals. She reached out to me and she said, we saw that you did this with the community. Would you consider publishing this in Collabra? A 1-year undergraduate thesis published in Collabra through the community. In addition, Timothy, who did 2 of these projects, also gave a brown bag at HKU. You can go and listen to him. We also have a Psychology Today column, so he summarized his entire experience. The best learning experience for researchers is to do a register report. And it's amazing how well he's done this. Everything reproducible, R markdown, all the way to the end. Really revolutionary, and it's amazing that undergraduates can do this in my courses. How many have we done? You can see all of the ones that have been published. You can go and click on those. You can see the ones that have in-principle acceptance, or we're going to finish them this year. So we've done a lot of these. So just goes to show that if you embed this with the thesis students, this can really be done. In addition, we also do this for meta-analyses, not just for replications. So we have one for meta-analysis, peer, community, and register reports on the action effect. And we also build templates. So if you're a meta-analysis person and you need a template, please go and use our templates. If you want to know more about register reports, or you want to know more about peer community, lots of things. Chris Chambers has like 100 talks on this. In addition, there are also articles that are summarizing what peer community does. Final question that you might have, this looks a little bit scary. Maybe some amazing undergraduates at HKU Psychology can do this. Can I do this? And my recommendation to you is give this a try. I think you'll be surprised, because it's so well structured, it's so straightforward. You can just follow what it is that we did. So for example, I have a registered report manuscript for you. So go and check this out. It's also on the Open Science Framework. And it takes you, if my undergraduate students can do this, it takes you step by step. Each section, what do you need to do? Placeholders to show you exactly what needs to fit in each, with notes, with instructions. So just go and check out our template. In addition, we have about 30 different resources that we've developed in order to help undergraduates or you to do these kinds of things. So another example, together with a lot of people in the open science community, if you don't know what effect sizes are, if you don't know how to calculate them, if you don't know how to aggregate them, all of that, we wrote a book together. And this is an amazing book, very high quality. So Matthew Jane, who is the first author. So the second and third are my former students at HKU. Now one of them is in Vienna, the second is in Chinese U. But then Matthew came in and really pushed this, boosted this to a whole new level. He is the statistical advisor for a journal that is well respected in psychology called Psychological Bulletin. So every meta-analysis in Psychological Bulletin goes through a review by Matthew. So Matthew, for a very long time, wanted to summarize for everybody, this is wrong, this is wrong, this is what you should do, this is what you should do. And now we have this book, and we have experts from all over the world, including the editor of Psychological Bulletin. So these are people who really know their stuff. So if you need anything about effect sizes, we have a lot of resources, and this is one of them. If you don't know how to do a power analysis, we have another book for you. So we just have a book on almost everything. How to do this? You can take everything that we have and do this on your own. If you need any help, I'm very happy to help you. Just so you know, everything that we do is collaborative. So if you use it, if you find some error, and tell us about this, or if you see something is missing and you add this, you are co-author. So just tell us what you added, and you're added automatically as a co-author. So everything is collaborative in the open science community. So you can take our resources and materials and run this on your own in education. We have a lot of completed replications, so you can take what it is that we've done and run this in your own context. We've done this with the Brazilians. So when I visited Brazil just before the pandemic, they were really excited about this, so they started to do exactly the same thing as us. They took our replications, translated to Portuguese, and ran this with Brazilians. It's amazing to see just how similar our findings are, and they're also able to publish these in great journals. Yeah, you can do any of those or anything else that comes to mind. If you have some other ideas, I'm happy to talk to you and support you. So we can collaborate. I can help you in whatever it is. So just communicate to me what is it that you need, and I'll aim to help you in your open science journey. So everything that I talked about today, I know it's a bit fast and overwhelming, but everything is on my website. It's very clearly outlined. Do not be scared to reach out. I don't know why some students are scared of professors, but even if I'm busy, I'll connect you with somebody else in the open science community. We have a lot of collaborators. We have a team of about 50 early career researchers from around the world. A lot of my students, even Timothy, is still here at HKU. He'll be happy to help you. So reach out to me. Tell me what it is that you need, and I'll do my best. If you want to know a little bit more about our activities, there's a YouTube channel. There's a mailing list that I publish every 2-3 months. And I'm also very active on Twitter X, now slightly moving to Blue Sky. But you can see a lot of our activities. So a lot of ways for you to engage with me or with the rest of the people in the open science community. Just tell us what you need, what is it you're unsure of, and we'll do our best to help. So that's it from me. If you want, I'm going to stay here. If you have some questions, happy to answer those.
So what are the outlets for the registered reports? So what are the possible outlets? Is it only you?
So you're in psychology, so it's easier for me to tell you what the outlets are in our field.
Yeah.
But for example, we have a very supportive new editorial in JPSP. So JPSP now does register reports. If you're doing replications, so replication register reports are accepted in psychological science. So a lot of these big journals are slowly having editorial boards that are embedding more and more register reports. So we had, I can actually show you the list. Yeah. So this is the list of all the ones that are updated to 2023. I hope this is still updated, but it's a list of over 350. But it does depend what kind of a register report you want to do. So not all of them support all of the types. So for example, some of them do replications, some of them do meta-analysis, some of them do qualitative research. You can filter for this. So for example, if you're in psychology, you can filter for psychology. You can see psychology is the leading one with 305. So you can focus on psychology, and you can say, for example, if this is a meta-analysis, which one does a meta-analysis? Yes. So you can see all of these journals support like a meta-analysis register report. If you want replication studies, let's do all of these, but let's focus on replication. So yes. Yeah, so very well-known journals here. You can just like browse this and see what matches for you. And some of them also have specialized categories, like in special issues and so forth. But best way is to just look at their guide for authors to see if they...
The host policy? Or
editors.
Or just the editors?
Yeah, the editors from Open Science that come in and change things and endorse this.
But they stepped down maybe.
It could change again, but I can tell you that when I told you that Collaborators in Vazir contacted us after peer community and register reports to say, oh, interesting, would you consider publishing this in Collabora? Sometimes I get emails from journals that do not have register reports because they don't know how to do register reports. And they trust the community, Chris Chambers, that they know how to do register reports. So when they see an endorsement from the community, they say, we would love register report, we just don't know how to do this in our journal. So please submit this after you finish with the community. Submit this to us. Yeah, I'm hoping to see more and more register reports. I feel like this is the future of science.